Okay, so a transformation from the plane R2 to R2, which is defined by multiplying a vector A by this matrix A, which is given by these values for a real number theta, which is representing an angle in this case. It rotates the vector V counterclockwise by an angle theta, or by the angle theta, because we had an angle theta here. Okay, so what we meant is that if V is a vector in R2 and we take A times V, then V would simply rotate counterclockwise by theta radians. Okay, so for example, consider this transformation in which theta is pi over 6 radians, which is 30 degrees. So if we multiply a vector V in R2 by A, then what it should do is that it should rotate the vector V counterclockwise by angle 30 degrees. So before we begin computation, let's review our trigonometry a little bit. Remember this pi over 6 or 30 degrees, it's one of the special triangles that you had. Alright, so what we have is that this will be square root of 3 over 2, or you can use your calculator to obtain it. So cosine pi over 6 is 1/2 square root of 3, and sine pi over 6 is negative 1/2. So let's take a vector V in R2 now. So let me take an easy to work with vector just for the sake of our demonstration. Okay, so excuse me. So I am going to take this vector 2, 2, and 2, 2 is going to make an angle 45 degrees with the axis of x. A reason I took it is that, we'll keep life easy. These guys will cancel. So let's go here, and here is the vector 2, 2, and I have put a prime here just to show transpose, because generally we like to write our vectors as column vectors. Okay, so here is our here is our vector 2, 2, and this angle is 45 degrees. And if we did this, if we multiplied A with the vector 2, 2, all right, then very quick review of the matrix multiplication shows us first what we get. We get this value, this entry times 2. All right, then this is going to correspond to this now. So we have negative 1/2 times 2. Okay, and then here what we will have, we will have this corresponding to that, and just multiply this matching with this and multiply the corresponding entries. So we have 1/2 times 2, okay, plus 1/2 square root of 3 times 2. Okay, so that is going to result in these will cancel, the 2's here will cancel, and the 2's here cancel as well. Okay, and this will become 1, and that's going to become square root of 3, right? So here we go, these guys cancel. So this is the value of AV, and remember this the angle made by this is how much? 45 degrees. And for this, so as we have this vector at an angle of tangent inverse 2 over 2, which is tangent inverse of 1. and that of course is 45 degrees if we take that in degrees. Okay, so let's look at the output here, or the resulting vector. So you have the resulting vector, this. So this will be at an angle, excuse me, at an angle tangent inverse of this second component over the first one, a y component over the x component, and we can try it directly. It doesn't want to give it to us at the moment. Well, no problem. We can either go back to the sum of the, the angle of tangent of angle of a sum, or let's try a different way. Maybe this will recognize that. That is, one moment here. Let's rationalize the denominator. Okay, by doing what? Just multiplying this by its conjugate. So you have square root of 3 plus 1 here. Okay, and for this one, let's do this here, and then we got this, right? And then what we have, let me just compute this separately for you. Okay, so that is how much? Let's just FOIL it. So it will be 3 plus 1 plus 2 square root of 3, right? And downstairs what we have? 3 minus 1, that is 2. Just a moment. Square root of 3. So this will be 4 minus 2 square root of 3 over 2, that is 2 plus square root of 3, right? Okay, let's see if it will give us an output for this. Okay, and so here we go. We got tangent inverse of this equals how much? Okay, good. 15 pi over 12. So this AV is at an angle of what? Equals 5 pi over 12, and of course the angle here is pi over 4. Okay, so pi, oops, sorry about that, pi over 4. Alright, so what happens? The difference of the angles is equal to how many? Simply 30 degrees, right? Okay, or I could have done this, or we could have done this, that is, could have taken this vector in our sketch pad and could have measured the angle there, and of course there we have to put decimal approximations. So this is 0.73, this is 2.73. So let me go there and ask it to plot these points and make a vector for us. So what were they? 0.73, 2.73. Okay, so it's plotted. All right, let's construct our vector then. Okay, and if we did this, say measured this angle, you can see the angle is approximately 30 degrees. Okay, and here I could not enter a column, so I just used the transpose. So let me know if you have any specific questions. All right.